Hello, John, and hello to all my classmates. I hope you are fine. Um, I'm. This is my term paper presentation entitled as Array fluorination reactions, that is aromatic CF bond formation via organometallic reagents. First of all, I would like to give some introduction towards the CF bond formation or CF activation. This is a reaction that involves the cleavage of any CH bond and introduction of any other functionality into whether it may be deuterium or it may be fluoride or something else. As far as we are discussing here the CF bond activation, so the cleavage of CH bond and introduction of fluorine to that bond is referred as CF bond activation. This can be done by using various substrates. It may be alkenes, arenes, aryl chains, or alkyl chains, or different aryl compounds, and it can be carried out through transition metal complexes to form the metal fluoride bond or through by fluoride hydrogen exchange process. This is a general scheme for the hydrogen fluoride exchange process in a resorcinol using acidic conditions, and this process is carried out um, uh, through catalysis. Now I would like to throw some light on the importance of the fluorinated compounds. The fluorinated compounds has again immense importance in every field of life. As especially here I would like to discuss some of its importance in the medicinal chemistry, drug research. So when in the medicinal chemistry, when the fluorine compound was introduced and the when marketed fluoride drugs the fluoride drugs have been like have came in the market. So they have various effects, or they have been widely used as anti-cancer drugs, as drugs that act on central nervous system, or drugs that affect the cardiovascular system. Furthermore, the fluorinated drugs have been used for the infectious disease or as well as for the genitourinary system. So the fluorinated compounds or the fluorinated drugs have gained various importance in the medicinal chemistry, as well as it has gained importance in the other fields of life. As there is so much importance of the fluorinated compounds, there are also some challenges that come across while aryl fluorination reactions. So some of them are listed here. Amongst them, due to the highly reactive fluorine gas, fluorine gas is unselective, and it is intolerant or to some common functional groups. Furthermore, the fluoride ion that act as a that is strongly basic and weakly nucleophilic in nature. So, due to its strong basicity, it often results in unproductive site reactions that could be very difficult to separate out from our desired products. So, these are some challenges that occur while the aryl fluorination reactions had been carried out in literature. So the classification of the allyl fluorination reactions, according to the literature, the aromatic carbon fluorine bond formations are divided into two major classes. One is the nucleophilic arene fluorination, and the other is the electrophilic arene. Our objectives of this presentation, term paper presentation, is mainly focused on the metal catalyzed arene fluorination, which is divided, as we already discussed, it is divided into nucleophilic arene fluorination and electrophilic arene fluorination. So we will discuss the platinum catalyzed nucleophilic arene fluorination, and platinum and copper catalyzed nucleophilic and electrophilic arene fluorination, and then we will go towards the conclusion. First of all, I would like to throw some I would like to discuss the nucleophilic aryl fluorine. So basically, the nucleophilic metal catalyzed nucleophilic fluorination is like the normal nucleophilic aromatic substitution reactions, where the fluorine atoms are introduced to electron deficient arenes. The reaction conditions that were used to undergo the aryl fluorinations are usually the drastic conditions, that is high reaction temperatures were used at high pressure, and the more time was used for these metal catalyzed nucleophilic fluorination reactions, and furthermore these reactions were carried out by using the phase transfer catalyst. So this is the general catalytic cycle for the metal catalyzed nucleophilic fluorination. Here, the fluorination was carried out by the first the oxidative addition that is followed by the halide exchange process, and further by reductive elimination we could get our desired product. Among the electrophilic among the nucleophilic fluorination, we will first discuss the copper catalyzed nucleophilic fluorination. Um, this is the first reaction that I would like to discuss under the heading of the copper catalyzed nucleophilic fluorination. Here, the halide exchange takes place at the aryl copper 3 halide complex. That was followed by the reductive elimination from copper 3, and we get our aryl fluoride complex. Uh, this is this, this is the catalytic cycle for the copper catalyzed nucleophilic fluorination. Here, the copper 1 was used as our catalyst, and the oxidative addition takes place here, and we got a copper aryl complex, after which the ligand exchange takes place, and the fluoride was the halide was exchanged with fluoride, and copper 3 fluoride complex was formed, which undergo reductive elimination, and we get our desired fluoride complex, and the uh, catalyst was regenerated to copper 1. As far as the reactions were concerned, with the same reaction, defluorination, nucleophilic defluorination was also tried to achieve. So the another possibility was of examining whether the aryl fluoride, that is this aryl fluoride, could be activated by copper 1 and undergo whether it can undergo defluorination or not. So therefore, by adding acetone as solvent and some excess of chloride, the defluorination takes place with the same copper 1 catalyst. So with the copper catalyzed nucleophilic reaction, we could be able to get the fluorination as well as defluorination reactions. Another example for the copper catalyzed nucleophilic fluorination is the um, aryl bromide, which undergoes the nucleophilic fluorination with the introduction of the copper 1 as catalyst, and also the silver fluoride as fluorine source. Here, the second example is the predenyl aryl bromide uh, substrate, which undergo the fluorination, and we got the predenyl aryl fluoride compound. The pyridine was used here as a directing group, and these are some of the advantages for the addition for the introduction of pyridine, which were listed here. This is the mechanistic studies which was done for this process, that the here the for first of all the pyridyl aryl bromide was introduced with the copper 1 catalyst, and uh, further the intermolecular oxidative addition takes place to give the copper 3 complex. Afterwards, the ligand exchange takes place with the silver fluoride, with the expense of the silver fluoride, and further the after the reductive elimination, we got our desired product. Now, after the copper catalyzed nucleophilic fluorination, we will go towards the platinum catalyzed nucleophilic reactions. Platinum catalyzed nucleophilic fluorination reactions takes place by using the aryl triplets as our substrate. Here, the cesium fluoride was used as the fluoride source, and cinnamyl platinum chloride was used as platinum as source for the platinum catalyst. These reactions were undergo at 12 hours and 80 to 130 degrees centigrade here. And the mechanistic studies after the for the mechanistic studies, it is the same as we have studied earlier, that is by the oxidative addition followed by the metal transfer, and then it was further followed by the reductive elimination. We got our desired product. But here the electron rich biaryl monophosphine ligand, that is the tertiary butyl bed falls. It was act as a supporting ligand for the reductive elimination here. Also, it as well as the supporting ligand, it also help us to prevent for the formation of the side products. So this was the main reason to use this electron rich biaryl monophosphine ligand in this reaction. Formation of the aryl fluoride reactions, and for this the mechanistic studies was same as we have studied previously. Now we will move towards the another category of the aryl fluorination reaction, that is the electrophilic aryl fluorination. So the metal catalyzed electrophilic aryl fluorination reactions were carried out using the electron-rich arenes, um, but the regioselectivity of these reactions were very low. This problem was overcome by using the organocopper and organoplatinum catalyst. Furthermore, these are the electrophilic fluorine reagents. Among them, this electrophore was used widely in different reactions. Here it is the general catalytic cycle for the metal catalyzed electrophilic fluorination. But as we seen in the nucleophilic aryl fluorination, the catalytic cycle is a little bit different. Here the transmetallation takes place prior to the oxidative addition, and then after oxidative addition, it goes towards reductive elimination, and we get our desired aryl fluoride complex. So this is a somewhat different catalytic cycle for the electrophilic fluorination, as we have studied for the nucleophilic fluorination reaction. So first we will go towards the platinum catalyzed electrophilic fluorination. This is done by using one of the example is by using the aryl boronic acids, which were used as a source of electrophile fluorination, and it was fluorinated to get the aryl fluoride complex. Here, the boronic acid was treated with the platinum complex. This was boronic acid was treated with the platinum complex through transmetallation. We get aryl platinum complex, which was further followed by the oxidative addition by using selectrophore, and then through reductive elimination we get our desired aryl fluoride complex. As for after mechanistic studies, the computational investigations were also carried out for this process, and the results were shown that the high valent platinum complex were required, and the stoichiometric amount of platinum were needed for to undergo such electrophilic fluorination reaction. Another example of the palladium catalyzed electrophilic fluorination is the catalytic fluorination of aryl trifluoroborates to aryl fluorides with the use of tertiary pyridyl platinum complex 2 as catalyst, and furthermore the selectrophore was also used as the electrophilic fluorine reagent. This is the intermediate that is formed during this reaction, that is the tertiary paradyl platinum complex 2 to 3. The mechanistic studies of this reaction reveals that the first turnover limiting oxidation of the bis tertiary pyridyl platinum complex 2 by selectro-4 uh, that affords the platinum 3, this one, and selectro-4 radical cation, which was further followed by the fluoride radical transfer from the selectro-4 radical cation to the aryl trifluoroborate, which form the CF bond and generates delocalized radical here, which after which is followed by the single electron transfer process, and we get our aryl fluoride here, and the catalyst is regenerated. So this reaction mechanism proposed for this aryl trifluoroborates undergo through single electron transfer mechanism. As far as platinum is concerned, after platinum, the copper was also used for the catalysis of the electrophilic fluorination reaction. This was the reaction that is carried out using the copper as catalyst. That aryl fluorination of aryl boronate esters that will undergo the electrophilic fluorination to get the aryl fluoride complexes, aryl fluoride compounds. Also, this is the yield of the different substrates. So it's also a substrate rich source for the electrophilic fluorination here. Instead of copper 1 uh, catalyst, the cationic copper 3 fluoride intermediate were used to react and to get the aryl fluoride compounds. So these were the some examples for the electrophilic fluorination. As we have discussed about the aryl fluorination, it has undergone two categories: electrophilic aryl fluorination and nucleophilic aryl fluorination. So for both of the categories, the platinum and the copper catalysts were used to carry out different reactions and to get the aryl fluoride compounds.